So this is sort of a late-breaking addition to the agenda, but I figured it might be nice to use some of our time to talk a little bit more about rxgk. I heard about this a little bit in the release team update yesterday. It's sort of the big main feature that we're thinking about for the next release. And so it merits a little bit more discussion. So just as a little bit of background, why do we need rxgk? The current security solution, such as it is for OpenAFS, is called rxcad. It's sort of derived from the Kerberos 4 that was state of the art 30 years ago when this was being developed. And then we had to tweak it a little bit to keep things working as the ecosystem evolved around us, but sort of the key features of it are still the same. 56-bit keys. We've had some experimental evidence to have people brute force recover the key for, I guess not quite for an AFS cell, but for a Kerberos principle that would be essentially the same thing. There was a commercial service that you could just hire somebody's basic farm to brute force a particular key. It was $100. Maybe it was even on sale for $20. List price is $100. And most people don't use the actual encryption on wire for bulk data because it's really slow. That sort of comes from a single desk being designed to be fast in hardware, but slow in software. It hasn't really been optimized because people aren't using it anymore. Modern processors are not like processors from 30 years ago, that sort of thing. And there is this integrity-only mode, but you basically have to do the encryption in order to compute it. So it's also very slow. I don't think I know anybody who uses rxcad integrity mode. And then this last one, I'll actually go into a little bit more detail about because the server can't tell the client that you need to use encryption. It's all up to the client's choice. And sort of the reason for that is because it's just coming from your Kerberos ecosystem. Everybody knows you have your AFS token that you use to authenticate to the AFS systems. But the way you do that, the way you get that is you request a Kerberos ticket from your Kerberos infrastructure, and then the AFS client basically just massages that a little bit, cuts off some field, shifts things around, and that's your AFS token. You don't have to talk to the AFS infrastructure at all in order to get your token. You just get it from the Kerberos stuff, and then you get to pick what to do with that. And so if your client is not configured to use encryption, you're not going to use encryption. And just a little bit more about that in this slide, which is just sort of a high-level picture, if you will, of the Rx security properties. So if we'll look at this is, I guess, a ladder diagram. So the client's on the left, the server's on the right, and they're sending messages back and forth. And so the client starts out, as I said, it has to pick what security you want to use. So that's whether or not to use rxcad at all, or if it wants to use rxcad with encryption, or just speed authentication. And then it's going to prepare the first packet of the RPC on the call. And if that's encrypted, it's going to be encrypted. If it's in clear text, that's in clear text. It's all up to the client's choice. So the client sends this first packet off to the server. The server says, hey, you're not authenticated. I'm going to challenge you. You need to authenticate to me. And so using the challenge, the client can make a response. The response is given through the token and an authenticator that uses the secret key from the token, which is really just the Kerberos ticket. So it's a shared key between the client and the server. And then the server can acknowledge that the response is in fact well-formed. The client considers it, the client is considered to be authenticated. And then the client continues sending the rest of the RPC request, whatever data is associated with it. And the server can send the RPC response back. But we notice in this that the very critical part is that the first packet of the call is already sent. And so if the server wants to have a policy to say you must use encryption, well, it's kind of stuck. The client has already sent the data in the clear if the client chose to send the data in the clear. And so from like an overall system security architecture point of view, this is not a great state to be in. So one of the things we want to do with rxgk is to change that, as well as improve away from the single desk level security. So to give this sort of listing of the rxgk features, we want to be able to use modern cryptography. We chose a long time ago to use basically the same cryptography as Kerberos 5. which means it's going to be extensible. We actually just defined, I think, a year or two ago, some new Kerberos encryption types, actually because NSA was asking for them. But that was sort of just getting rid of SHA-1, so we're using SHA-2 instead of SHA-1. It's not really a big change yet. But we could define some newer ones in the future. You know, some people like Cha-Cha 20 is a stream cipher, fast and software. So we've got the option to do that in the future. But you know, right now we expect people to be using AES with rxgk, so the state of the art. A lot faster, you've got the option for hardware acceleration. You know, different sorts of processors that will do that. We also have this integrity only mode that's actually faster than confidentiality, so people might use that. And we have the ability to do this negotiation of what parameters and behavior we expect to get. And so, you know, rxgk itself is going to be, you know, those features from the previous slide, but over the years, it's been 10, 15 years people were talking about this. And so I kind of get bigger and bigger. You know, this is the catch-all name for everything nice we want to do that's vaguely related to security. So of course, in this first bullet with the actual bulk data protection on the wire, that's a big part of it. We also take this opportunity to modernize how we use cryptography, use more key derivations. We're not sharing cryptographic keys in ways that rigorous mathematical analysis tell us are bad, right? So might make us susceptible to actual cryptanalysis, people doing mathematical analysis. We also have the ability to use the GSS API instead of just pure Kerberos. Part of this is because, in general, everybody recommends that you should not use the raw Kerberos protocol. It's a pretty ugly protocol. The GSS API is a little bit higher level, a little bit easier to use. But additionally, you also get a lot more flexibility from that. So you don't have to use Kerberos. GSS and G is for generic. So if you have some local authentication mechanism, shim that in. You could do something with TLS client certificates. You could tie that into like a OAuth IDP or OpenID Connect. There's a lot of different options for sort of site-specific customizations. As I said, compliance already with this explicit negotiation. We also wanted to put in the ability to have both per host and per user credentials. That's pretty powerful in a couple ways. The initial incentive for introducing that was this idea of cache poisoning. So, you know, the current model of RxCAD, you've got your own personal credentials, and that's what's used to authenticate data transfer from a file server. But if you're on a dial-up, where there's other users there who might be using the same AFS cache, the same AFS client, you can actually inject some data into the network, at least in theory, and spoof the response from the file server. Because you know the key that would be protecting that data, because it's just the key from your Kerberos. And so you could say, not return the actual data from the file server, return some data of your own choosing, but that gets stored into the cache on the cache manager, and the other user on that dial-up can see that same cache data. So you can essentially give corrupt data to the other people on this machine that you're sharing it with. And so that makes people pretty uncomfortable, compliance point of view, it doesn't look so good. So the idea is that you can have some trusted credentials for the machine itself, and that will ensure that the cached data is actually correct for all of the users. But once you have that, you can also say, I've got these two identities, I can do some combined access control. You can talk to Jerry a bit more about the actual practical implications of that and the rich policy that you can use once you have those tools available. I sort of mentioned up above the robust key hierarchy. Right now, for your servers, you just got one key for all the servers, whether it's a database server, a file server. So they're all sort of equally trusted. You can't really put a file server in some departmental group that you don't really like as much, because if they have that key, they can do anything to your cell. You see people doing separate cells instead of just having these file servers within the broader cell that are a little bit less trusted or only trusted for a specific domain. The list goes on. We can also give sort of robust support for multi-instance Kerberos principles. I mentioned several slides ago, RxCAD comes from Kerberos 4, which had just the two components. You have a user, or I could have like kaduk.root, but I couldn't have something really complicated, which Kerberos 5 people don't use very much, but you could in theory, have a A/B/B/D/D as a Kerberos principal in Kerberos 5. You have sort of arbitrary nesting structure to that. rxgk will let you do that if you want to. I sort of mentioned the non-Kerberos GSS mechanisms on the previous slide. This secure callbacks bullet point is a very short name, but it's sort of a pretty big feature that people have been asking for. Right now, in current architecture, there's the concept of a callback. When you make a request to a file server, the file server can give you a promise to say, hey, I'll let you know if this data changes. But the way we actually do that signal is basically just a single bit of information. It might either be an Rx import.
No, for a callback,
it's just, but it's just a single sort of, the callbacks are broken. It's not authenticated at all. There's no possibility of getting more detailed information about what exactly has changed or has not changed. So when you get a callback break, it's kind of a heavyweight operation. You have to go refetch or revalidate all of the data that's involved. So if you have a secure callback channel, you can both get a reliable signal and also get final grade information. And you can sort of see this is a very broadening of the scope from the initial just make the security cryptography better. And while we're here, we'll put some more extensibility in. Right now, the token format, as I said, is just this modified Kerberos ticket. But we can put a little pool in there that you can show whatever you want. So if you were going to do some site-specific customizations on your file server, you could put some extra data in the token. You maybe a little bit more authorization information or restrictions on what you want this particular credential to be able to do. So there's a lot of power in the potential opportunities there. And this last bullet, sort of opportunistic security for anonymous clients. What I have in mind for that is basically anonymous PKNet. So you can do like a Kerberos Diffie-Hellman key exchange to get a shared secret between two parties without necessarily authenticating the client. You might still authenticate the KDC in a Kerberos environment, but that's a way to say, even on a AFS client that doesn't really have credentials, it doesn't have a user that can log into the system, you can still have a way to encrypt your data over the wire. Sort of generally improves your privacy position in this modern day and age when the NSA is sniffing all your traffic.
So it's a feature for anonymity? That the
Yeah, you can still be anonymous, but get some protection from the data on the wire. And there's probably some more things I missed in terms of what people might be thinking about when they say rxgk. And so if you want to get back into the details and say, well, I was just talking about this broad picture of what rxgk might mean to some people, but if we want to really drill down and look at how do we do this, of course, the first bullet point, the packet level protection mechanism, that's the key thing we want to hone in on. But we also are going to need some new RPCs to actually do this cryptographic negotiation, get your token from the AFS server as opposed to from the Kerberos server. We're going to need a new RPC in order to get these per file server keys registered in the system. And then we have to be able to leverage the existing key agreement mechanisms. So that's sort of a code for using the GSS API, sort of existing infrastructure that you might have in your deployment. And we provide a fairly standard way to make use of that. And drilling down a little bit more, question? So if we want to drill down a little bit more, the past slide is sort of the concrete of what we need to do in order to get rxgk. We sort of mentioned this rxgk phase 1 yesterday, and that's what we've actually done. So rxgk phase 1 is a sort of Garrett's topic, sort of a set of commits that has been entirely merged into master. And so that is going to be provided in the core packet protection, very important. The ability to print your token, if you already know the secret key for the cell, you can sort of pretend to be anyone. You have a sort of standardized way to say I'm the super user, and it's pretty straightforward to do. And given those first two things, that means you can get a strong cryptographic protection for connections where you're using ATS localauth command, or if you're doing your database server to database server connections, that sort of thing. So it's a much reduced from this very broad initial scope, but it's something concrete and does actually work. And we also mentioned, I think yesterday, that we might start a 1.9 series of development releases. So to get this sort of mode of what's concrete. The concrete things that would be in these releases are the rxgk phase 1, so you can have your PT server and your VL server and use rxgk to talk to each other. But then that next bullet point is to say that we don't have a way to require that they do so, partially because it would kind of disrupt it to just install a new version and say, okay, you must be using rxgk on your existing systems. You can just go talk to dev null. So we didn't put that in quite yet. But we also have the options for the VOS and the BTS client commands to be able to make queries to the database servers, so you can actually see that this stuff is working. We've got the way to generate random rxgks that does not involve manually figuring out the file format and assembling pieces, which is what I was doing the first few times I was testing this. I was literally saying, here's my 4-byte header, I write that out, I get my 16 bytes of random data, we append that to the end of the file. It was kind of cute, to know that I could figure out what the file was supposed to look like, but nobody should have to do that to actually test this stuff out. And so, of course, if we're reduced scope for the 1.90 additional version, there's a bunch of stuff that's not in that. So we don't have regular user authentication using your first credentials to the database servers. We don't really have the security parameter negotiation quite merged yet. And we don't have the file server all the data transfer yet. And there's some other parts that we still need to think a little bit more about how we're going to do. Mostly with the per file server keys, we need to actually get the new VLDB format. I think Mark, we were talking about that yesterday with some of the other stuff we have going on. And we don't really have a concrete plan for the secure callbacks. That was one of the really kind of out there things that people might mean when they talk about rxgk, but it's not really a core part of rxgk. So we haven't really been focusing on how to do that explicitly. So I've told you a lot about what we've been doing, what we think we're going to be doing. How can you help? There's a lot of things you can do to help. We're going to have the new development releases out, so if you could install those on your test cell, make sure it works, do a little bit of a stress test, see what breaks. We'd love to hear about things that are working, things that aren't working, so we can get them fixed. And it's also good to have some real practical experience with, we do have this huge set of new features. How are we going to deploy them and get them rolled out in a safe and roll-backable way? If something goes wrong, we don't want to be stuck in a situation where we've got to take an outage to roll back and go to the previous state. So right now we've got, I think, basically a command line argument to the database servers that says you should use these things when you're talking to each other for your outgoing connections. And that's pretty simple. You might say, I'm going to install the new software on all the machines in a staggered fashion, but I'm not going to change the configuration at all. And then once the new software is everybody, you can say, okay, I'm going to enable the new feature, again, in a staggered fashion, machine by machine, let them all synchronize again, make sure it's working well. But we don't really have a detailed written procedure for exactly how to do that. We don't have the documentation, and we haven't really worked through all of the rollback scenarios. Does this actually cover everything you might need to do from an operational perspective to actually deploy this in production? So we've got some of the things maybe some of the people in the room have a lot of experience thinking about, so it would be really helpful to get perspective on that. Similarly, we know we're going to have to change the database format for VLDB, and that's even a little more complicated than just turning on a new feature. So we might think about, if we know we're going to have this new format, is it going to be in the same file, is it going to be in a different file? How are we going to actually do the conversion of the format? Are we just going to say there's a flag bit? I'm using a new format now, so there might be some new stuff in there. If it's a completely new, new structure, there's no overlap at all. maybe that's going to be in a different file, and we're going to have a flag for I'm using the old file versus the new file. There's a lot of complicated things that might go on to actually get this deployed again in production without taking outage. And so to have a good procedure for just how to do that in general would be really helpful. This is not something that we've done, I think, since OpenAFS 1.2 to 1.4 was the last change in the database format. And I believe at the time we just told people you got to take an outage. So you install the new version on all the database servers, you have them all down, and bring them up again from scratch essentially. And in the modern era, that's not really something we want to ask people to do. You can't tell people you got to take an hour outage for your entire cell. It's just not going to fly. So that's sort of the high level design stuff. Of course, there's going to be code review. There's still several changes in Garrett under the rxgk topic, which have been unchanged for a few years, but many of them did not get fully reviewed. We sort of have been dancing around this topic of pthread versus LWP. The sort of core problem there is that for rxgk, we said we're going to use the GSS API. We're not going to implement the GSS API that's already done, like MIT Provide or Heimdall or somebody else has implemented the GSS API. But everybody who's done that is using pthreads for their stuff. And we can't link pthreads and LWP together because that's just going to cause things to explode. So if we have any AFS tools that are still using LWP, we cannot convert those to the GSS API to the rxgk. And so first we have to say, stop using LWP, we're going to use pthreads, and then we can sort of enable rxgk support. And so there's a few things left that are still using LWP. There's a lot of things that we're building both the pthread and the LWP version of. Pretty straightforward to just stop using the LWP version. For some of the other ones, the conversion, in most of the case, is not going to be very complicated. It's sometimes it's a simple, just a straightforward copy and place. For like there's an IO manager select, then you just change that to a standard select. If you're interested, come and find Andrew, me, maybe Mike's shaking his head. So you can find him and we could sort of walk through some examples of what that's like. And there's just some other general code maintenance that would make it easier to do this sort of conversion. I have this laundry list here, but that's not really a limitation or necessarily even represented. But there's a lot of things that we could do that sort of help us get the code base ready for the broad sweep of changes. So that's all I've got. Thank you. I welcome lots of questions.
Well, just to mention, so now that we have, so I was waiting for phase one before I really looked at any of the other stuff.
Right.
After that, I think I did have some changes in some of the subsequent commits. So I was just mentioning that, like, I was assuming you weren't having plans to update the commits after that.
I have no concrete plans to touch the commits right now.
Yeah. Oh, I meant like, yeah, in the immediate future. Obviously, at some point, if nobody does it, I'm assuming you'd look at it. But right. I was just going to say I was probably going to do that hopefully soon. Unless you wanted.
I'm happy to hear it.
Unless you wanted to do that. I just
no, I have plenty of stuff on my plate.
Yes, that's what I imagine.
I'm happy to offload the load. Did you want to talk about what would the phase two look like?
I'm assuming phase two would just be user authentication. So, actually having users be able to use it.
So like using tokens to talk to the database servers, basically.
Yeah, I mean it's still the same. It's the commit stack that you had originally pushed. Like everything you had completed up to that point, basically. And just nothing more. None of the advanced things
things that are in the GitHub. Or?
Yeah, the GitHub branch that you had. That's just what I was thinking. Basically, what was there.
Yeah, that sounds good. I think there was also a little bit of conversion for the box server as well. That may or may not be ready to land.
You mean the rxgk conversion or the pthread conversion?
Both, I think.
Yeah. Well, because the pthread conversion is a separate topic, but
yeah.
Maybe I guess it's maybe dependent. So
it is.
Yeah, so it would just be rebased on top of
that. Talking to the point you said about when you were talking about combined identities, the reason one of the reasons that's interesting is for overcapacity compute. So if you have applications that can run out in a lesser security zone, so you can say, well, that node and that cluster can access this data in my database, in my enterprise, in my private cloud, it allows you to burst out into that was some of our DOE customers were really interested in that.
And I think there's potentially even some thought work about what would the combined identities mean in all the cases. You've got these two things, you're required to both be present, you require either of them to be present and you're authenticated. You might want to have a more complex
Access control expressions,
language,
positives and negatives, and
so there's a lot of possibilities.
It's a lot,
but getting the details in place.
Right. We made some decisions.
Yeah.
No one's going to be happy.
You document what you're doing. People can read the documentation and choose if it's going to be a good fit for what they do.
Right. And it's not something that an end user would be doing. So
yeah, it's pretty helpful stuff.
Your last slide mentioned file server auto tune. How extensive do you envision that being?
Well, so that's sort of a little bit of a call out to a change that I started a few years ago and haven't really had to touch, have a chance to touch. I started looking at it a little bit as well. The sort of key insight there was that even if you use the -L argument for file server, it was called large file server. That's something that was large in 1990. So it's pitifully small.
Yes, I thought the big change, the conceptual change was instead of having small, medium, large, you specify like amount of memory.
I just wanted to add an X, an XL. And that got shot down because then someone said, well, then we're going to need an XXL. And then the next year we'll need an XXXL.
Yeah, so it's tough to keep updating those because people don't want, like, you change the defaults and everything.
You don't like sign any change.
Wait, you've been using that for 25 years.
Yeah, and suddenly it changes and it like breaks or something. It works in some way people don't like. So I thought is there a change for something that like you specify an amount of RAM that we're?
Yeah, there's a
that's
script
a
here
good
that
work.
tries to do it where you say, I want to use this much memory. And then it goes and say, okay, I got this much memory.
So we use
And then it allocates the
Threads that you
parameters
want.
based on how much memory you give for that file server.
Yeah, but it's not even things that are specifically for allocating memory. It's just that's a good gauge on how much resources you have to spend. So it can still auto tune other things like number of threads or something like that.
Yeah, the number of threads affects the memory usage.
Yeah, but it's not specific. It's not like we're counting exactly how much memory each thread uses and like counting that towards a quota or
We're
something.
not like using a hard cap.
It's just it's very saying like small versus large is very subjective. So if you say I want you to use like 12 megabytes, that's it's very different from a machine using that has like 12 terabytes of RAM.
Right. So like for me, my large machine might be the 12 gigabytes of RAM, but maybe the 700 gigabytes of RAM is going to be large for somebody else.
Yeah, and that just helps provide reasonable defaults. So you may tune things, but
Yeah, you might need to further tune things.
just
Yes, it decides on what the defaults for that amount of memory that you.
I guess one thought that might be interesting too is to do it somewhat dynamically. Because with PA file servers, et cetera, you can restart things pretty much and look maybe even every hour and optimize it based on what activity last hour and restart.
That's a very good thought. You could be collecting data.
Because that's realistically kind of what you end up doing anyway.
That's
Yeah,
true.
the trouble.
But it depends on the file server. Some you never touch.
Well, the trouble
Others,
too with automatically figuring out a lot of that stuff is there are some parameters which don't have a clear, like there's always trade-offs. So if you have more, like you can always have more callback space, but it always uses more memory. So you need something to specify like the limit. So certain caches,
but you tell me there is no limits. Well, no, actually, just double it,
Keep doubling it.
Yeah, I'm up to 40 million now, so,
Yeah.
and only a single volume with is double.
yeah, but there's reasonable defaults to give, and
Yeah,
currently they're not reasonable right now. So
Yeah, currently the defaults are not reasonable, and you've got to specify like 10 different items to get something that's usable.
So I guess in a way, it's not really auto tuning. It's canned defaults based on the size of memory you're saying for that machine.
but you could
Now,
make
that
the
would be useful though.
Yeah. Well, we could also make the default be like, half the RAM in the machine, so you can detect it.
Yeah, I
Or
thought
something
about that, but like Java tries to do that. They try to use all the memory on the machine.
Yeah. So
It's
I-
really frustrating.
You can use something of order of magnitude,
especially on a file server, you kind of have to, how effective caching is of the file system, like, yeah, that's really effective, I found. Even on the client. What was that?
You're talking about the caching layer.
Yeah, the OS caching of volumes is like, at times can be really, like, wow, look at the performance of that.
Yeah, I think that's
Everything's cached in memory.
It's too fast.
And even on clients, so.
There's no IO, like no IO.
Any other questions for Ben? Thank you.
Thank you, Ben.